The title of this presentation is Inconvenient Data, Part 2, Analysis of Climate Change Based on Sea Surface Temperature Data. Now, the fact that this is called Part 2 implies that there was a Part 1, and in fact there is a Part 1. However, the title of that YouTube video is simply Inconvenient Data, a new analysis of climate change based on actual data. If you haven't watched that video, you might want to do that before watching this, the current one, Part 2, because the previous Inconvenient Data video laid a lot of the background information and that will be referred to during this Part 2 presentation. Well, one of the important things that we're going to bring out in this YouTube is that no supercomputers are needed to understand climate change. The consensus of scientists base their dire predictions on supercomputer simulations of the effect of CO2 on climate change. Now, in Part 1 of these dual analyses, I derived a model of global temperatures on Earth, simple enough to be run using the calculator app on a cell phone. And in this analysis, I'm going to demonstrate that, in fact, all you need to understand the effect of CO2 on global temperatures are a pencil and a ruler. Now, I know you're going to find that impossible to believe in the basis of the consensus of scientists' complexities, but in fact, it's true, and I'm going to show that to you in this presentation. Before we get to that, though, I want to just briefly summarize the results from Part 1. The major result was that global temperature data are composed of two main components: a natural cyclic climate change consisting of 5 periodic oscillations, and an anomalous warming starting in mid-20th century that may in fact be caused by CO2. This anomalous warming that might be caused by CO2 took place at an average rate of about 0.37 degrees centigrade per century. 0.0037 degrees per year. Very, very tiny amount of warming. The total anomalous warming that may be due to CO2 is about 0.2 degrees centigrade. Well, this analysis is all based on real measured data. Where does the data come from? The Hadley Climate Research Unit at the University of East Anglia in the United Kingdom maintains 2 climate data sets. The average global temperatures for every month from 1850 up to last month. This is called the CRUT data set. The other data set that I'll be using is the average sea surface temperature for every month since 1850 up to last month. Now, the sea surface temperature is measured by actual ships, ocean-going ships, and by floating buoys in the ocean. And then the global temperature is found by adding in some mysterious way that sea surface temperature data with the land-based thermometer measurements from weather stations all around the world. The analysis in Part 1 used only the global temperature data. This analysis in Part 2 will primarily use the sea surface temperature data. Okay, there are 3 topics that I'm going to be covering. I'm just going to show you the first one here. I'm going to show you how to derive a model of the natural climate change component of total climate change based on sea surface temperature data, and I'm going to demonstrate that the cyclic climate model that was developed in Part 1 accurately represents that natural climate change component. Okay, so we've talked about the global and sea surface temperature data. This is a plot of those data. Temperature on the vertical axis and years, and I've only, on the horizontal axis, I've only plotted it from 1900 up to 2020 because all the significant conclusions can be drawn with that reduced span of years. So the red line is the estimated global temperature data. The blue line is the estimated sea surface temperature data. As we can see in the first half of the data, the first 100 years, first century of the data, the sea surface temperature data and the global temperature data were essentially the same. It's true they wiggled up and down and so forth, but basically they wiggled up and down together. And you can see these temperature changes that are shown inside this ellipse were completely natural because they started long before CO2 became an issue. But after the mid-20th century, global temperatures, which is the red curve, rose faster than the sea surface temperatures. Now, this may in fact be evidence of warming caused by CO2 or other greenhouse gases. The amount of that warming is the difference between the global temperature, the red line, and the sea surface temperature, the blue line. So we've got two different data sets, one measuring sea surface temperature, one measuring global temperature data. Well, one way to compare two data sets like that is by using a thing called a scatter plot. Scatter plot shows how global temperatures depend upon sea surface temperatures rather than how they change with time. So a scatter plot is created by picking a date in the data records and then figuring out what the global temperature was on that date, plotting that on the vertical axis, finding what the sea surface temperature was on that same date and plotting that on the horizontal axis. And so you come up with one dot for every date in the climate data record. Now you can see in this particular case for November 1932, the global temperature data and the sea surface temperature data were in fact equal. Well, in fact, any data point that falls on this 45-degree line indicates that the global and sea surface temperatures were the same on that date. Any data point that falls in this pink shaded region indicates that the global temperatures were above sea surface temperatures. So data points that fall in the pink shaded region are indicators of potential warming caused by CO2. Okay, so what do the data look like? This is what the data look like. There are, I think, 1,200, 2,300. There are a lot of data points here, one for every month for the last 165 years. You can see that in the early part, when the global temperatures were lower than they are today, for the first century of the data, the global and sea surface temperatures were essentially the same. And that's indicated by the fact that all the data points tend to cluster around that 45-degree line. So this behavior where global temperatures and sea surface temperatures are equal can be interpreted as the natural state of the climate because this was the behavior of the measured data before CO2 became an issue. But in more modern times, recent global temperatures have been rising faster than sea surface temperatures, so that the scatter plot in the upper region shows the data, global temperature data was above the sea surface temperature for all of those dates. And the difference then between the 45-degree line and those data points is an indication of anomalous warming that may be caused by CO2 and other greenhouse gases. Okay, so it's time now to get out our analytic tools, the ruler and the pencil, to draw a straight line through the anomalous data points. And you can see then, based on this sophisticated analysis, the magnitude of the warming that may be caused by CO2 is only about 0.17 degrees centigrade. So all we've done here is to plot the data and draw two straight lines, one the 45-degree line and one straight line through the anomalous data points at the upper end of the curve. Without any analysis at all, we can draw two important conclusions. The first is that the natural state of the climate is for global temperatures to be equal to sea surface temperatures on the average. That's the lower left portion of that scatter plot. Second important conclusion is that the magnitude of global warming that may be caused by CO2 is only about 0.17 degrees centigrade. Okay, in part one of the analysis, I showed that natural climate change is composed of 5 periodic components. I developed an analytic model consisting of 5 periodic components that matched the measured global temperature data from the Hadley research unit. So the analysis of global temperature in part one developed a model of natural climate change. The model consisted of 5 different periodic oscillations. The oscillations have been going on for at least the past 165 years, and the oscillations have nothing to do with CO2 since they all started long before CO2 became an issue, and they have persisted unchanged to this day. So what do we have now? By scatter plot, we concluded that the sea surface temperature data, which is the green line on this plot, that the sea surface temperature data and the global temperature data would be the same if there were no CO2 warming. That means that the green line, the sea surface temperature data, is a valid proxy for natural climate change in the absence of CO2. Now the red line is the analytic model developed in part one of the natural climate change component of the cyclic climate model. And as you can see, the red line predicts very accurately, or should say matches very accurately, the measured sea surface temperature data, except for the large spike around 2016, which was due to El Nino, and I'm going to talk about that in much more detail later in this presentation. So the fact that these two curves, the measured data and the analytic model, match one another demonstrates that the natural component of the cyclic climate model accurately represents global temperatures if there were no CO2. Okay, so we have derived then a model of natural climate change based on sea surface temperature data. The next topic is we're going to derive a model for just the CO2 component of climate change. This is going to be based entirely on sea surface and global temperature data, and I'm not going to use curve fitting in this derivation. There are some people who erroneously believe that results obtained by curve fitting have no predictive ability. Although that is entirely false, I thought it was important to show that it isn't necessary to use curve fitting in order to draw all the significant conclusions that there are about climate change and the effect of CO2 in that climate change. So as we mentioned before, the evidence of CO2 warming is in the difference between global temperatures and sea surface temperatures. Prior to about 1970, the difference between global and sea surface temperatures was roughly zero. It varied up and down like random noise, but the average value of the difference was zero, indicating that there was no anomalous warming due to CO2 during those years. Now, this doesn't mean that the temperatures were not changing. It means that they were changing equally together. Sea surface and global temperatures were going up and down during that period of time, but they were going up and down together such that the difference between them stayed at roughly zero. And these changes were not caused by CO2 since they started basically in 1850. Well, the consensus of scientists, climate scientists, tell us that the evidence of CO2 warming should appear as an upward linear trend in temperatures. And if you look at the difference between global temperature and sea surface temperature data here, getting out our ruler and pencil again, we can in fact draw this nice straight line, and it looks quite reasonable that this is in fact the evidence of CO2 warming that the climatologists have been searching for, that we see an upward linear trend. After 1968, global temperatures rose above sea surface temperatures at an average rate of about 0.4 degrees centigrade per century. Well, that's all very great, except the anomalous warming, the actual data, doesn't fit the linear trend that is supposed to be indicative of CO2 warming. This simple linear trend doesn't fit the data after about 2005. In fact, the anomalous warming that may have been caused by CO2 actually stopped in 2005. After 2005, global temperatures have remained about 0.17 degrees centigrade above sea surface temperatures. The difference between global temperature and sea surface temperature, that is to say, the possible effect of CO2 and other greenhouse gases, has remained constant since 2005 at about 0.17 degrees centigrade. So the actual anomalous warming that may be due to CO2 actually looks like this. Once again, we could have drawn these lines using a pencil and a ruler. I actually did an analysis to do least mean squares fit and so forth. But I could have drawn these same lines freehand without even using a ruler, and the conclusions would have been the same. So what we found is that prior to 1968, there was no detectable warming due to CO2. Between 1968 and 2005, warming is possibly due to CO2 and other greenhouse gases, was occurring at an average rate of about 0.5 degree centigrade per century. But after 2005, the warming stopped. It reached a value of about 0.17 degrees centigrade and stopped, and it has been at that level since 2005. So here we have a model, the solid lines here are a model of the anomalous warming that may be due to CO2, derived from a simple analysis of the sea surface and global temperature data. Well, there's another model of the effect of CO2 on global warming. The Intergovernmental Panel on Climate Change, the consensus of scientists, use a kind of sophisticated simulation of the warming component that may be due to CO2, and that is plotted here in this green line, faint green line. So the blue line is the actual CO2 warming data from the Hadley Climate Research Unit. The red line is the simple CO2 component of climate change that we have just derived based on sea surface temperature data. And the green line is the IPCC model of CO2 warming. This shows that even supercomputers can produce incorrect results if that's what they are programmed to produce. The green line is completely incompatible with the measured data. So what we've got then, after task 1 and 2, we've got a model of the natural component of climate change. We've got another model of the CO2 component of climate change. When we add those two together, we come up with a composite model of global temperatures, which match, as you can see in this chart, very well the actual measured global temperature data since from 1900 up to 2010 or something like that. You can see that there's this spike due to El Nino, which looks ominous, and I'm again going to talk about that a little later. So here the blue line is the measured temperature data, the black line is the original cyclic climate model developed in part 1 YouTube video. The red line is the new sea surface climate model derived in this video based on the difference between measured global temperatures and measured sea surface temperatures. So what we see here is that future temperatures are expected to lie someplace in this shaded region. More importantly, global temperatures are expected to be relatively constant for at least the next 35 years. You can see that starting now, the temperature is going to go up a little bit, then it's going to go down a little bit, then it's going to go back up a little bit. But on average, the climate is either going to be roughly the same as it is today, or in fact, possibly even a little cooler than it is today. So much for the dire predictions of a climate catastrophe. The data do not support the conclusion of a climate catastrophe coming in the near future. The global temperatures after the El Nino event have in fact fallen back to the model predictions following that El Nino event. So even though it looked in 2016 as if the global temperature really was increasing rapidly towards some kind of a catastrophe, since the peak in 2016, the global temperatures have in fact fallen right back to where the cyclic climate model developed in 2015 predicted they would be. A year ago, they predicted what they would be today, and that's what they are today. So we've finished with the first two topics. The last thing we're going to talk about now is a more detailed analysis of the El Nino event of 2015-2016. And what I've done, this is the same global red line and sea surface temperature data that we've been dealing with all along. It's just that I've expanded the year scale to make the El Nino event stand out more. So what we see here is that the El Nino event started in 2013 and remnants of it persist today. Both the sea surface and global temperatures started to rise in 2013. And global temperatures peaked in February, March of 2016, but they have fallen since then. Well, what we found out previous analysis is that the average difference between global and sea surface temperatures since 2005 have been about 0.17 degrees centigrade. So if we take the global temperature data, the red line here, and we shift it down by 0.17 degrees centigrade, it makes it more obvious what happened during the El Nino event. So that's shown here. Once again, I've expanded the year scale even more. This is only 2013 to 2017. So what we can see here is that the rise in global temperatures, which is the red line, after 2013 was caused by rising sea surface temperatures. I'm claiming that the ocean caused the atmospheric temperature to increase because the contrary opinion that the atmospheric temperature caused the ocean's temperature to increase is scientifically implausible based on the laws of physics and heat capacities and so forth. So apparently, the oceans released a significant quantity of heat into the atmosphere in 2016, causing this global temperature spike. But you see that after that sudden upward spike, both global and sea surface temperatures have been falling. And in fact, as of the latest data that's available, which is November of 2016, the global temperature data has fallen back to precisely what the cyclic climate model predicted back in 2015. The blue line is the prediction of the cyclic climate model. The black line is measured temperature data. And as you can see inside the oval, right now the measured data tends to agree with the model prediction very closely. Okay, so what are our conclusions? First of all, between 1850 and 1968, global temperature was the same as sea surface temperature. The majority of climate change since 1850 has been caused by natural changes in sea surface temperature, which have then impacted the global temperature data. Since 1968, there's been a small additional warming that might be due to CO2, but that global warming that might have been caused by CO2 stopped increasing in 2005, and it's remained fairly constant at 0.17 degrees centigrade ever since then. And global temperatures spiked in 2016 due to the El Nino event, but they have now returned to normal following that event. And global temperatures are expected to remain relatively constant for the next 35 years at least. Okay, well, there's a companion book to this video. Its title is just Inconvenient Data. The book contains extra information, including a detailed analysis of the weather. It describes how the cyclic climate model was computed. Available in both print and Kindle versions. So if you want more information about these topics, please go to Amazon and you can buy the book.